Chapter 6, Section 2, Quadratic Equations. We have already discussed how to solve a quadratic equation, and we discussed this, I think, a little bit in Chapter 3 when we finished factoring. And as of right now, the only way that you know how to solve a quadratic equation is by factoring. Well, in the remainder of this chapter, what we're going to do is we're going to learn 3 other ways to solve a quadratic equation. So a quadratic equation is an equation with a degree of 2, and we already know that. A quadratic, anytime you see that squared or a second degree equation, you know that it is a quadratic. These equations have one squared term. Standard form of the quadratic equation is this. This is ax squared plus bx plus c. There are many methods to solving the quadratic equations, and like I said, you already know one, and that's going to be factoring. So let's review that. Here we have a quadratic equation. I know that because of the squared term, and the way that you know how to solve a quadratic equation is by factoring. So the first thing in factoring is look for something in common, and we have a 7x. That's in common. So if we factor each one of these by 7x, if we divide a 7x out of each one, we'll have x minus 2. And now that we have 2 factors, we take each one of these and set them equal to 0. And so for the first one, we get x is equal to 0, and for the next one, we get x is equal to positive 2. And remember, when you're solving a quadratic, you should get typically 2 answers. Now, sometimes these answers will be real numbers, sometimes it'll be fractions, sometimes it'll be radicals, sometimes it'll be imaginary numbers. All of that is going to come into play when we solve these quadratics. So you know that when you graph a quadratic, anytime you graph a quadratic, it's going to be a parabola. And so what we're doing is we are finding the x-intercepts. So for example, this particular parabola would have an x-intercept at 0 and an x-intercept at 2. And so it would look something like this. And we're going to use this in Math 112. So if we look at this problem, on the left-hand side, it does say solve by factoring, but on the test, I'm not going to tell you how to solve it. I'm just going to say solve. So I'm just going to give you a list of quadratic equations and ask you to solve them. So for this one, you can solve it by factoring, but at the end of this chapter, you'll know other ways to solve. And so if you don't want to solve it by factoring, then you don't have to. So for example, this one, since it does say solve by factoring, and that's the only way you know right now, we'll go ahead and do this. This is a trinomial. Your leading coefficient is not 1, and so we are going to use bottoms up. And so we'll have x squared plus 29x plus 120 is equal to 0. And then we'll refactor this. And so we'll have x times x and plus, and I think 120 divided by 5, 24 and 5. And then we're going to divide out the 4 that we multiplied in initially. We'll reduce, so we'll have x plus 6, and bring up, because this won't reduce, so 4x plus 5 is equal to 0. And then we're going to take each one of these factors and set them equal to 0. And then we'll solve, and so we'll get x is equal to negative 6, and x is equal to negative 5/4. And so remember, when you have these quadratics, you are going to have 2 answers. So in this section, or in this chapter, make sure when you solve a quadratic, make sure you do come up with those 2 answers. Okay, so you know how to solve by factoring. Now what we're going to do is we're going to solve using the square root property. And so you know when you see this x squared, for x squared is equal to a, then you know that x is equal to the square root of a. Remember, we learned this, to get rid of this square to solve for x, you take the square root of both sides, and so that's where this comes from. So x is equal to the square root of a, or x is equal to the opposite of square root of a. And so that's where your 2 answers are going to come from when you're using the square root property. Again, we use this in chapter 5, this plus or minus symbol. So remember, this plus and minus symbol means you can get the positive square root of a and the opposite, the negative of square root of a. So for example, when you have an x squared and you initiate, in other words, you put in that square root symbol, that's where your plus or minus has to come from. And remember, your index cancels out your power, and so you just get x is equal to the square root of 81 is plus 9 and minus 9, plus or minus 9. Okay, in letter B, in order to do what we did in letter A, you have to have that x squared term by itself, so we're going to divide both sides by 3, and so we'll have x squared is equal to 15, and now you're going to initiate, in order to solve for x to get x by itself, we're going to take the square root of both sides, so the square is going to cancel out the square root, and you get x is equal to plus or minus, and you can't break down, you can't simplify the square root of 15, so you are going to get the square root of 15. Alright, so let's take it a little farther. What if we have a group that is squared? Well, the process is still the same. We've got to get rid of this square in order to get to this x. So to get rid of a square, you're going to take the square root, and so the square cancels out the square root, and you get x plus 4 is equal to plus or minus the square root of 100 is 10. So you have two problems here. You have x plus 4 is equal to 10, and you get x plus 4 is equal to negative 10. And so to solve this, we minus 4 from both sides, and we'll get x is equal to 6, and then we'll minus 4 from both sides, and we get x is equal to negative 14. So that's where your two answers are going to come from. Okay, just like on the previous slide, we had to get our x squared term by itself. Well, we have to get our x squared grouping by ourselves as well, which means we need to get rid of this 2 and we need to get rid of this 5. And we learned in chapter 2 that you've got to get rid of your addition and subtraction first. So we're going to minus 5 first. Don't divide by this 2 just yet. So if we minus 5 from both sides, we're going to get 20. Now you can divide everything by 2, and so what we're going to have is 5x minus 2 squared is equal to 10. And now you can initiate your square root. You can put in your square root, and so what you're going to have is you're going to have 5x minus 2 is equal to plus or minus the square root of 10, and you can't break down the square root of 10. So now I need you to understand that this plus or minus goes with the square root of 10. Okay, all of that goes together. Don't ever try to break that up. So now what we're going to do is we're going to solve for x. So we're going to add 2 to both sides. Well, when I add 2 to both sides, I'm going to get 5x is equal to 2 plus or minus the square root of 10. Can't put those together because you can't put whole numbers and radicals together. And then I'm going to divide by 5. And so we're going to have x is equal to 2 plus or minus the square root of 10 all over 5. And this is going to give you some decimal, but I don't want you to give me the decimal. I want you to give me this answer here. Alright, so I want you to try page 309. Try these problems. Bring them into class if you have any questions.